Hi everyone, today we're looking at Module 5, Lessons 3 and 4, and we're going to start looking at linear functions and proportionality. Now, Lesson 3 starts with linear functions and proportionality. And the proportionality that we're talking about is in the constant rate of the function, which is represented by our slope. So the first goal that we're going to have today is that students relate constant speed and proportionality or proportional relationships to linear functions using information from a table. So what that tells us is that we're going to be able to look at a data table and identify the constant rate. And we're also going to be able to say students know that distance traveled is a function represented by time. And that the cost of an item is a function of the number of items sold. So these are two real-world scenarios where we have what we typically look at as a linear equation, which is actually a function because one of our variables is very much represented by the other. Example 1 says Walter walks 8 miles in 2 hours. What was his average speed? So this is a pretty simple equation to set up. I say I'm walking 8 miles per hour. Miles is going to be represented by my y value, hours by x, but I can just simplify 8 over 2 equals 4 miles per hour. If we assume constant speed, which means Walter is walking at 4 miles per hour from the time he starts to the time he finishes, we can write an equation 4 over 1 equals y over x. And then we cross multiply and we get a linear equation, y equals 4x. And that's helpful because now we can solve the distance that Walter travels for any given time. So by incorporating his constant rate as our slope, we can really determine how far he traveled no matter how much time he spends walking. Our second example talks about selling bags of candy. So we have bags of candy as our x variable, our input, and the cost of that bag is our y variable, our output. So for one bag, it costs $1.25. 2 bags is $2.50. 5 bags is $6.25, and 8 bags is $10. And this is a linear function because there is a constant rate. And I can prove that constant rate using the slope formula. In this case, my graph is also a line, so it'd be really straightforward to see that this is a constant rate problem. So $10 for 8 bags of candy is going to be $1.25 per bag. $6.25 for 5 bags is $1.25 per bag. Basically, any value that I examine in my table gives me a slope of $1.25 or 1.25. So when I plug this back into the equation, I can solve for the cost of my candy no matter how many bags I want to purchase. Module 5, Lesson 4 is more examples of functions. The first thing we're going to focus on is that students recognize real-world functions as discrete or continuous. So students recognize real-world functions as discrete, and then students recognize real-world functions as continuous. So the word discrete may be a little unfamiliar, but the word continuous should give you a hint that when we talk about continuous functions, we're looking at a function that at any point on my line I have reliable data, where a discrete function is only going to be reliable for given x values. So some examples, when I think about distance traveled, the seconds that I walk compared to the feet I actually travel, this data is, even though there are specific data points, this is continuous data because as time is passing, I'm continuously moving. And even though I've measured 0.5 seconds, 1 second, 1.5 seconds, 2 seconds, I could look at, say, 1.83 seconds and find an exact distance traveled because that type of data is continuous. In terms of my bags of candy sold, 1 bag is 125, 2 bags is 250, 3 bags is 375. This data is discrete. It's not continuous because I'm not going to sell any quantity of candy between 1 and 2 bags. I can sell 1 bag of candy, I can sell 2 bags of candy, but there's not really a reason that I would sell 1.5 bags of candy. So I'm not looking at data in between the x values that I've been given. So again, my candy data is discrete, where my distance traveled data is continuous. And that's because I can stop at any point along the graph. Whereas discrete, I would only observe data of given x values. So continuous data, or continuous rate, is also not always linear. So again, when I look at that data, it doesn't have to be a straight line to be continuous.